Okay, so in this video, I will discuss question 3 of homework 2. And question 3 is pretty simple algebra. And the first two questions are straightforward, so I'm not going to discuss them. But the last one is tricky, and I don't see anyone who has a perfect answer. Let me show you why. So skip the first two. If you want to see the answer, you can read my answer. So in part C, what you have to think about is this matrix. So x tilde is x1 comma x2 tilde, the fitted value x2, and it is a matrix like this. So you have to, like x tilde is the fitted value, you have to consider a more complicated form, x2 tilde, as, in the question, x2 tilde takes this form, right? x2 tilde is defined this way. So plug that into here, and then it's a little bit complicated, but you should be able to get this matrix. So this is where your confusion starts, like, oh, it's too complicated. Yes, but let's do it step by step carefully. Now what we need to check if it's full rank, and its 2x2 determinant is AD minus BC. So this is the determinant. Actually, I made several algebra mistake by myself when writing this, and I think this is right. It may be wrong, but I tried multiple times, and I think it's correct. And it's actually very simple in the end. You can simplify this form. So what we need is the determinant non-zero. We want this determinant to be non-zero. That's the full rank assumption. And the determinant is gamma 2 squared times something. So for this to be non-zero, both of them should be non-zero. So this is like in the question, you may wonder why there are two conditions. One condition which is more familiar, but what is this? What is this? This is because, so this part, the second part is implied by this. And what still remains is gamma 2. For gamma 2 to be non-zero, you need additional condition. So you first have to derive the formula for gamma 2, which is also very annoying algebra, but possible if you do this. And then the numerator is not 0 if and only if this is different. Okay, so we use two conditions. We need two conditions, and that is intuitive because the first condition implies no multicollinearity between these two guys, right? No multicollinearity between these two guys. And the second condition is that gamma 2 is non-zero, which means the instrument is correlated with the endogenous variable. So the second condition is like the relevance condition, right? Relevance condition and full rank assumption. So they are very natural assumptions if you understand them, but algebra is very annoying. So refer to my answer if you had any problem. And let me continue to question 4, but numbering problem. So this is on extended triangular equations because like x affects s, and then s affects f, and another variable affects anyhow. So it's like it's like connected to each other, very complicated way. So the reason why I'm considering this extension is because when there are only two equations, you may think it's too obvious. right? That's obvious. But when it becomes a three equation system, then you have to think about what kind of assumptions is needed and when the model is identified and when not. So the exclusion restriction is more clear. Like, so like for example, in this approach, Z2 is an excluded variable. So Z2 does not appear here. So the instrument is excluded from the main regression. Similarly, when you have another like two-step endogenous variables, then you have to have instrument for each of them, right? So S affects W, and then S and W both affect F. So then what you need is separate instrument for each of them. So this is, and they have to be both excluded from the main regression, right? The final third stage regression. So I will call this first stage, and this is the second stage, and this is the third stage. So you need 3 steps regression, and part A and B are pretty standard. So you did well. Most of you have done pretty well, and it's easy to show that something is identified. That's true. So, you know, like it's simply extension from two-dimensional two equations case, but a problem arises. Suddenly your confusion starts again here, from here. I'm going to show you what happens. Like, so the hint is multicollinearity, but please, I'm telling you the answer. I told you the answer is non-identification, and the reason is multicollinearity. Then just do not copy the same words again. I know I told you the same thing, so copying them doesn't have anything. So if you write that way in your exam, it'll be 0 point, right? You have to explain where the multicollinearity is coming from and why multicollinearity causes the failure, something more, right? Let me see. So here, broad idea is multicollinearity, but I find no perfect answer. Like, this is not about discussing the multicollinearity in this case. Let me see if there is anything. But all of you have quite correct intuition. I think highly of that, but not perfect one. Maybe this answer I think is most complete. So if you plug in the things, then you have these two coefficients on exogenous variables. But and you know, delta, gamma, delta, pi, gamma, pi, delta can be identified from the first 2 stages. But the problem is still you have 3 unknowns, alpha, beta, lambda, from 2 informations. The information you have is coefficient of x and coefficient of z. Even if you know the first 2 stages parameters, still there are 3 more unknowns. So that's the problem, right? Same idea, same intuition holds here. You can identify coefficient of x, coefficient of z. If you know delta, then you can recover alpha. Alpha is identified here, but beta and delta cannot be separated without, even if you observe, even if you identified pi. Okay, if I explain it this way, this may be still confusing. So let me the best way to show that is simply showing this. So this is the multicollinearity. So we will be regressing the outcome on 2 fitted values of endogenous variables and z, which is now included in the main regression. Then it's pretty clear how they are correlated with each other. And part D, another multicollinearity, clear. So now you see why alpha is identified here because multicollinearity happens between these two guys. So W's coefficient is identified, as you can see from this argument, right? So that's correct. Excuse me. And so final question is, now X is included but S is not, then how can we identify that? To show that, I checked the exogeneity assumption and full rank assumption. Exogeneity is not a big problem. I believe it's trivial. You can show that. But in the regression, full rank assumption should be checked. And we know when there are only two regressors without intercept, then the full rank assumption is like this. The full rank assumption is a matter of correlation between these two guys. So you can calculate the correlation and check if it's 1 or not, plus minus 1 or not. So the correlation, it's also annoying algebra, but possible. So this is the correlation squared. So correlation is not 0, not plus minus 1 if this part is non-zero. So for this part to be non-zero, what you need is just these two assumptions. So, right? So actually, the main point is this part. If this guy is 0, automatically this part is also 0. So what you need is you need to have non-zero term in here. Then correlation will be not equal to 1. So that's the full rank assumption you need in this case. So, and this is intuitive. Delta is non-zero. And so first, this is obvious. The instrument should have some variation. The variance of instrument is not 0. And delta is not 0. Delta is like here. Delta is you can think it as the correlation between W and Z. So W is the only endogenous variable in your main regression. So for identification, W must have some correlation with an instrument. That is Z, right? S is not a problem because X will handle this part. So Z is required to identify alpha. I mean, delta is non-zero. So that effect of Z varies W, which can identify alpha. That is the intuition here. Okay. So when you have three equations, you can play with that. Like just make up another model and see if it's identified or not. So it'll be a very interesting practice. Okay, this is the end of homework 2. And I understand the algebra was very dirty, but I still appreciate your effort. And good luck with your exam. And let me know if you have anything else. Any questions? Let me know. I would be very happy to help you. Okay. See you later.